Have you ever wondered what happens behind the scenes when you share a playlist with a friend on Apple Music? Today, we'll use stack mapping, a tool that helps visualize the different layers of technology involved in an app interaction to uncover what's happening beneath the surface. By the end of this short video, you'll understand what it means to download content from the internet, from servers and database, how to stack map a simple interaction, which different roles and technologies contribute to sharing a playlist. So let's get started with stack mapping, the process of sharing a playlist on Apple Music with my friend Sam. Before we can share a playlist, we'll first need to stack map how we browse Apple Music and access the playlists. First, let's open Apple Music on my Mac, but imagine I'm hidden away in a cave in the middle of the mountains with zero internet connection. What do you think happens when I try to access my playlist? As you can see, my screen looks rather empty. Why is that? It's because the music isn't stored on my computer. It resides on servers and databases somewhere out there. Until I connect to the internet, I can't access it. Or in other words, download it. Now let's connect to Wi-Fi. Voila, look how quickly the playlist appears. But how did this happen? Let's stack map this interaction. So on the front end or the client layer, you can see that I'm using the Apple Music app on my Mac. This app makes a request to access all relevant playlists to a server. On the application layer, the requests go to Apple's playlist server, which processes the request. The server might check who's making the request and ensure everything is valid. The server then queries the playlist database, which stores all the playlist information. Think of the database like a fridge. It stores all the essentials until we need them, just like how the database stores playlist information until the app requests it. The playlist database sends back the relevant playlists, including details like the brand name, album cover, and price to purchase. The playlist server processes this information and sends it back to the Apple Music app. That's how I now see the playlist available. So by requesting to access the playlist, we've engaged all three layers of the stack working together seamlessly. This was our first request, and as you've seen, it's impossible for me to share an Apple Music playlist without having internet access in the first place and having downloaded them. Now let's move on to our second interaction, the one we wanted to stack map. As you can see, I'm clicking on Moon Music by Coldplay and viewing the details of this particular album. I can now click on Tell a Friend and can now add Sam's email address. I click Send, and from my point of view, their interaction is completed. But actually, what happens when I click Tell a Friend? Let's find out. I'll divide this interaction in two parts. Part 1 is about sharing the playlist with the playlist server. So on the client layer, I'm still using the Apple Music app on my Mac, but this time I'm making a new request to share this playlist by email with Sam. In this first part, we won't be using a database. It doesn't do a lot in our context, and so you can see that not always all three components of the stack have to be called on every occasion. So in this context, this is where an API comes into play. The sharing server requests to an email server via an API to send the information and receives a confirmation that it did. So now our sharing server has received a confirmation the email has been properly processed. It sends me a confirmation that it indeed did so. And this is our part 1 completed. Now let's move to part 2 about Sam receiving the email. On the client layer, this time Sam's now using the Gmail app on his iPhone. This time he's making a new request to download all new emails from the email server. So on the application layer, the email server requests to the email database all relevant new emails for Sam, which includes the latest one sent by the Apple Music sharing server. And on the data layer, the database sends the information back. The server processes the information, and Sam receives the email and can click on the link. So by requesting to share the playlist, we've once again engaged in all three legs of the stack. And you've now seen a simplified but coherent stack mapping of an interaction you might perform daily. On roles and technologies, now let's connect this to real-world job roles and the technologies involved. On the client side, we're likely to find a front-end engineer. The engineer uses coding languages like JavaScript or Swift and a corresponding framework like React.js for JavaScript and UI-Kit for Swift. React and JavaScript are mostly used for web applications, while Swift and UI-Kit are used for applications like the macOS Apple Music app. Everything related to the Tell a Friend button, the design, placement, and functionality, as well as the interface where I input Sam's email address, was developed by a front-end engineer using these technologies. On the application and data layer, we're likely to find a back-end engineer. For the server side, the back-end engineer uses coding languages like Java and C#, with corresponding frameworks like Spring Boot and Microsoft.NET. For the data layer, the engineer uses tools like SQL and MongoDB. This everything related to managing the process of information, recording data into a database, and making applications speak to each other via an API. I hope you found this useful, and next time you use an app, try to think about the different layers at work behind the scenes.